This is another important topic. Simply, multivibrators are producing or generating non-sinusoidal waveforms. Let us see in detail now. So, multivibrator is the electronic circuit which is used to implement two-state devices, two states. So you can get two states at the output of the multivibrator. So two states refers to two voltage levels at the output. So for example, we have the two states. Each multivibrator can produce two states. So one state can be logic low. Another state can be logic high. So why we call into the digital world, we call this logic low as a 0 and then the logic high as a 1. But if you talk from the analog point of view in voltage level, this logic high means it indicates plus 5 volt or plus 12 volt. It's based on the circuit design. And this 0 is indicating 0 volt. Practically, it is not 0 volt, it's plus 0.3 volt, around 0.1 to 0.3 volt. But we don't consider this, we consider this as a 0 volt. Okay, so multivibrator can produce two states, either logic high or logic low. Two states refers to two voltage levels here at the output. So for example, it can be a 0 volt and 12 volt, or 0 volt and 5 volt, or 0 volt and 10 volt. So it's really depending upon the circuit design. Many times two voltage levels are also represented as either logic high or logic low. If you use this multivibrator in the digital world, in digital circuit design, then you consider this as a logic high, logic low. But if you use this multivibrator in analog circuit design, you are also considering this a logic low, logic high, but not in terms of binary level 0 and 1. We consider plus 5 volt and 0 volt. These 0 and 1 are binary numbers. So this is called binary. Bi means what? Bi means two in English. So this is having two different values for the signals, zeros and or 1. So entire digital world is only considering the signals in terms of zeros and ones. So that is based on the CMOS logic and CMOS. Okay, I think then we will just go to another direction. So we will come back to the multivibrator now. It's very useful in digital electronics. Which one? This is the multivibrator circuit is very useful in digital electronics because storage of binary numbers, we use the flip-flops. Flip-flops can also use this multivibrator in its design. And this multivibrator can also be used to count clock pulses. For example, in timers, you can use multivibrators. And also to generate non-sinusoidal waveforms such as rectangular waveform or square waveform or sawtooth waveform or triangular waveform. So any other than the sinusoidal, that is called a non-sinusoidal waveforms, you can generate by using these multivibrators. Okay, so this is just any kind of circuit. This circuit can produce two states, and these two states can be either logic 0 or logic 1 in the digital world. And it's useful in quite many applications, especially in digital electronics. This is very useful. So multivibrators can be classified into three categories. One is called astable multivibrator. Second one is monostable multivibrator. And this one is bistable multivibrator. So you can see the common term stable, stable, stable. And we have astable. Astable means none of the states. So each multivibrator can produce two states. So no state is stable. Both states are unstable. That's why we call this as an astable multivibrator. So whatever the state produced by this multivibrator is not stable. It will keep changing, keep changing. So maybe 1 second it will produce logic high, and the next second it will produce logic low, and then logic high and the logic low. This is the logic high state, and this is the logic low state. So two state, the same cycle will repeat again and again. In monostable means what? Monostable means one state is stable, another state is unstable. I will explain what is that exactly means in a while. And the bistable multivibrator means both states are stable. We will see now. Astable multivibrators. The astable multivibrators does not remain stable in any of the two states. So this is the output of the multivibrator. So it can produce two outputs on logic high and logic low. So this is the state 1 and state 2. That's why we call this as a two states. And two states are going to repeat again and again. So it, for example, it's logic 1, and then the output immediately changes to logic low. And automatically it changing back to logic high, and then automatically going down logic low. So it's changing again and again by giving without any external trigger. So that is why we call this as an astable multivibrator. So, and the output of the multivibrator continuously changes between these two states. So the output of this is the output. We are making this graph. Y-axis is indicating output. X-axis is based on the time. So at T1, the output is logic high, plus 5 volt. At T2, output of this multivibrator is 0. Maybe this is a plus 5 volt. And the time T3, this is going to logic high, plus 5 volt. And then at T4, this is going down. So with respect to time, this amplitude is keep changing, keep changing. So this is changing the state by itself. That is why this is called astable or unstable multivibrator. The example of the astable multivibrator is relaxation oscillators. We saw, right? Oscillator means what? Oscillator is just oscillating back and forth from from high to low voltage. So here also it's oscillating. This is a high and then low and then high and low, high and low. It's oscillating back and forth, but producing non-sinusoidal waveforms. So we use this kind of circuit design in relaxation oscillator designs or relaxation oscillators. So now you should understand multivibrator means it has two states at the output. Astable multivibrator means none of the state is stable. It will keep changing. Now the second one is called monostable multivibrators. So it can also produce two states. So in monostable multivibrator, the output remains stable in only one state. But remember here, so here, for example, logic low. So the multivibrator output is or remaining, or it's just staying in this off state, logic low state permanently. Until how long? So until you give some kind of external trigger. So in case if I apply some kind of external trigger, this is the clock signal or the trigger signal. Whenever I apply this external trigger to this circuit, then immediately the stable state will get disturbed and it will go to unstable. It will go to the logic high. Logic 1. So after certain period of time, it will automatically go down. And then it will stay in this stable state forever until you give another trigger pulse. For example, now I am giving another trigger pulse. In this trigger pulse, then immediately this will go up. And then after certain time period, it will automatically come down, and then it will stay in this another stable state forever until I give another external trigger pulse. So what is trigger? What is trigger? Trigger means that is the large amplitude. Let's say this is the definition for trigger. So you can see here, I give the large amplitude, but for a very short duration, very short period of time, I am giving this to change this stable state to unstable state. So this is changing from 0 volt to 5 volt, and then it's just for certain period, and then it will automatically come down. So this is called monostable. So it means mono means what? Mono means one in English. So this is only one state is stable. Only one state is stable. The other state is unstable. Okay, in monostable multivibrator, there is the definition, you can read it. Whenever an external trigger signal is applied, the output immediately goes into the unstable state. After some time, it comes back into stable state again. So after some time, for example, let me take the pen, different color. So this is the time period of unstable state. So I maybe, because in the circuit design, I fix this time, maybe 10 seconds or 10 millisecond. So 10 seconds, it stays in the unstable state, and then it will go back to the stable state. The stable state, it can stay maybe 20 seconds, 30 seconds, 40 seconds. We don't know until we give the trigger pulse. So whenever we give the trigger pulse, then immediately it will go back. It will go to the logic high. It will stay another 10 seconds, and then it will go back to the stable state. So here it means only one state is stable, another state is unstable. So this state only stays temporarily for 10 seconds and then automatically coming back. This is not unstable. Sorry, this is unstable and this is a stable. So only one state is stable. So we call this as a monostable multivibrator. So the time required to come back into the stable state, this 10 second, for example, this time period is determined by RNC value. When we see the circuit design, you will see how the circuit looks like and where are these RNC value. By changing this RNC value, I can change the timing. So we know, for example, now we know the formula 1 divided by 2 pi RC. So by changing this RNC value, I can change the frequency value. The frequency, based on the frequency, we can calculate the time, right? What is the time period? T is equal to 1 divided by F. So this is called time. This is the standard formula. I think you should remember this. So it's not a matter, it's a sinusoidal or non-sinusoidal. So this is 1 cycle. So this is called 1 cycle or 1 hertz. So 1 hertz. This is a frequency. How can I convert this frequency into time? Time is equal to 1 divided by frequency. So 1 divided by 1. So now this is equal to 1 millisecond or second. The unit is really depending upon the x-axis I choose. So maybe let us say this is 1 second. 1 second is too much for 1 cycle, but this is just for an example. So we can once you know the frequency, then you can calculate the time. So for example, if I want 10 seconds unstable state, then I can choose the value of R and C in the circuit. Then based on this frequency, then I can decide this. Similarly, if I know this 10 second, now I know that T is equal to 10 second. Then how can I calculate the F value? F value is equal to 1 by T. It's very simple, just opposite. I bring this T here and F here, or I can keep the F here and then T here. So from the frequency value, I can calculate the time, or from the time I can calculate the frequency value. So once if I know the frequency value, I can use this formula. And if I know one value, for example, a capacitor, then I can find the R value. For example, if I know the frequency, based on the time. Then I can find the capacitor value, for example. So capacitor is C is equal to 1 divided by 2 pi r f. So this frequency I brought it down. So I can find this C value. And the resistor I need to assume, or I need to use another mathematical derivation to find out. So this is how we have to design the circuit in practical. So one state is stable and one state is unstable. This is mono stable multivibrator. So this type of multivibrators are used in timer, timer and also in many other applications. We will see the applications later when we see the detail of the monostable multivibrator. Okay, so far we had seen astable and monostable, and then the last one is called bistable multivibrator. So bistable means both states are stable. So we have the state 1, logic high, stable 1. So this is the state 1, STATE, and this is a state 2, and this is a logic 1, and this is logic 0. Okay, these are two states the multivibrator can produce at the output, and both states are stable means, okay, so here you can see this is staying infinity time until it meets the trigger pulse. So I give the large amplitude, short duration trigger pulse, then immediately this got disturbance, and then it just go down to the state 2, that is the logic 0. And this is also very stable, and this stays infinity in this voltage level until I give another trigger pulse. So now I give another trigger pulse, then immediately it's changing back. What happens in the monostable? The monostable, it's not like that. I give the trigger pulse, it's changing from one state to another state, but automatically it comes down after some time. Right? But here it's not like that. So here both states are stable. It will stay in this voltage level forever unless you give the trigger pulse. If you give the trigger pulse, then immediately you are changing from this state to another state. And here I am giving this one to here. For example, here I don't have any more trigger pulse. So this state will stay long time until I give another trigger pulse. So both states are stable. That's why we call this as a bistable multivibrator. So the output used to be in any one of the two stable states. Either it can be logic 1 or logic 0 forever. And whenever an external trigger signal is applied, external trigger signal, large amplitude, short duration applied, then the output goes from one stable state to another stable state. So I call this as a stable state because the output stays forever until I give the trigger pulse. The stable state 2 is also stable because it stays forever here until I give the trigger pulse. If no triggering action is applied, then it remains in the stable state, in the new stable state forever. So this is the basic idea about bistable multivibrator. So example, bistable multivibrator is used in the flip-flop circuit. Flip-flop. In electronic, this is one of the very important component we are using. Multivibrators are three different types: astable multivibrator, monostable multivibrator, bistable multivibrators. You know the working principle or the basic idea of each. Each can produce two states. Here, two states are unstable. Here, one state is stable, another one is unstable until you give a trigger pulse. Here, both states are stable. And if you want to change from one state to another state, you must give a trigger pulse in both states. So all these three types of multivibrators can be designed by using either operational amplifier or transistor pairs or 555 timer IC. So you can remember, you can implement this multivibrator using either of these components, of course together with R and C. So the major component is operational amplifier or transistor pair. Pair means what? Two. So we must use two transistors to implement one multivibrator. So transistor pairs or 555 timer IC. So